Never connect the ground wire to the neutral lead in the breaker. A neutral wire is used in 120 volts or 240 volts electrical systems to complete the electrical circuit. It provides a path for the current to return to the power source. A ground wire is designed to provide a safe path for electrical current to flow to the ground in the event of an electrical fault. It helps protect against electrical shocks and fires. Neutral and ground wires are both important for electrical safety, but they serve different purposes. The neutral wire carries current, while the ground wire does not. It is dangerous to connect these wires together. For a hot tub installation, follow these steps. Firstly, install a double-pole ground fault circuit interrupter, GFCI, breaker and electrical panel. This will provide ground fault protection. Secondly, run a 3-wire cable, black, red, green, from the breaker to the hot tub. The green wire is the ground wire. Thirdly, connect the black wire to the load terminal on the breaker and the black wire on the hot tub. Fourthly, connect the red wire to the L2 terminal on the breaker and the red wire on the hot tub. Fifthly, connect the green ground wire to the grounding lug on the hot tub and to the ground bar in the electrical panel. Do not connect the green ground wire to the neutral lead in the breaker, as this could create a hazardous situation. It's crucial to understand the distinct roles of neutral and ground wires in electrical systems to ensure safety. The neutral wire serves as the return path for current in a circuit, while the ground wire provides a safe path for fault current to flow back to the source, protecting against electrical shock. Connecting the ground wire to the neutral wire, especially at the breaker, can have dangerous consequences. Firstly, it can create an alternate path for current flow, potentially energizing the ground system. This could lead to electrical shock hazards if someone comes into contact with a grounded metal object. Secondly, it can cause nuisance tripping of ground fault circuit interrupters, GFCIs. GFCIs are designed to detect imbalances in current between the hot and neutral wires, indicating a ground fault. If the ground and neutral are connected, some current may flow through the ground path, causing the GFCI to trip even when there isn't a true ground fault. Thirdly, it can compromise the effectiveness of the grounding system. The purpose of the grounding system is to provide a low impedance path for fault current to flow back to the source, allowing the circuit breaker to trip quickly and clear the fault. If the ground and neutral are connected, the grounding system may not function as intended, increasing the risk of electrical shock and fire. When installing a hot tub, it's essential to follow the manufacturer's instructions and local electrical codes carefully. Here are some general guidelines. Firstly, install a dedicated circuit for the hot tub. This ensures that the hot tub has its own power supply and doesn't overload existing circuits. Secondly, use a double-pole ground fault circuit interrupter, GFCI, breaker. A ground fault circuit interrupter, GFCI, breaker provides protection against ground faults, which can occur if there's a short circuit or insulation failure. Thirdly, run a 3-wire cable from the breaker to the hot tub. The 3 wires are typically black, red, and green. The black and red wires are the hot wires, and the green wire is the ground wire. Fourthly, connect the black and red wires to the appropriate terminals in the breaker and the hot tub. Be sure to follow the manufacturer's instructions for proper wiring. Fifthly, connect the green ground wire to the grounding lug on the hot tub and to the ground bar in the electrical panel. Do not connect the ground wire to the neutral bus bar. The ground bus bar is typically located in the electrical panel and is connected to the grounding electrode system. Electrical codes, such as the National Electrical Code, NEC, provide detailed requirements for grounding and bonding electrical systems. It's important to be familiar with these requirements to ensure that the hot tub is installed safely and correctly. Firstly, Section 250.96 addresses bonding other enclosures. Where other metal raceways, cable trays, cable armor, cable sheath, enclosures, frames, fittings, and other metal non-current carrying parts are used as grounding or bonding conductors, they shall be bonded where necessary to ensure electrical continuity and the capacity to conduct safely any fault current likely to be imposed on them. Secondly, 250.130 equipment grounding conductor connections. Equipment grounding conductor connections at the source of separately derived systems shall be made as specified in 250.30 AON. Equipment grounding conductor connections at service equipment shall be made as specified in 250.24 AON, 250.24 ATWR, or 250.24 A3. For replacement of non-grounding type receptacles with grounding type receptacles, and for branch circuit extensions only in existing installations that do not have an equipment grounding conductor in the branch circuit, connections shall be permitted as specified in 250.130C. NEC Table 250.122 provides minimum sizes for equipment grounding conductors for grounding raceway and equipment. 250.122b increased size. When grounded conductors are increased in size from the minimum size in 310.15b16 or 310.15b17 for ampacity adjustment, temperature correction, or both, the equipment grounding conductor shall be increased in size proportionately according to the circular mil area of the ungrounded conductors. 250.122c multiple circuits. Where a single equipment grounding conductor is run with multiple circuits in the same raceway cable or cable tray, it shall be sized for the largest overcurrent device protecting conductors in the raceway cable or cable tray. 250.122d reduction of size. Equipment grounding conductors shall not be reduced in size. 250.122 a raceway or cable armor as equipment grounding conductor. Where circuit conductors are installed in a metal raceway or cable armor, the raceway or cable armor shall be permitted to be used as the equipment grounding conductor when all of the following conditions are met. Firstly, the raceway or cable armor is listed for use as an equipment grounding conductor. Secondly, the raceway or cable armor is installed in accordance with the applicable requirements of this code. Thirdly, the raceway or cable armor is continuous and electrically connected to all boxes and fittings. Fourthly, the path to ground has sufficiently low impedance to limit the voltage to ground and to facilitate the operation of the overcurrent protective device in the circuit. Fifthly, the overcurrent protective device is sized so that it will trip before the raceway or cable armor is damaged. Here is some additional information about grounding and bonding. Grounding is the process of connecting electrical equipment to the earth. This provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Bonding is the process of connecting different metal parts of an electrical system together. This helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. Grounding and bonding are essential for electrical safety. By following the requirements of the NEC and other applicable codes, you can help to ensure that electrical systems are installed safely and correctly. Remember, when dealing with electrical installations, it's always best to consult with a qualified electrician to ensure that the work is done safely and in accordance with local codes. Electrical safety is paramount, and proper grounding and bonding are critical components of a safe electrical system. In addition to the points already covered, let's delve into some more detailed aspects of grounding and bonding in electrical systems, particularly as they relate to sensitive equipment and minimizing electrical noise. Firstly, single-point grounding. In sensitive electronic equipment or installations where minimizing electrical noise is crucial, a single-point grounding system is often employed. In this approach, all ground connections are routed back to a single central point, typically a ground bus bar connected to the grounding electrode system. This helps to prevent ground loops, which can cause circulating currents and introduce noise into the system. Secondly, isolated ground receptacles. Isolated ground receptacles are designed to provide a separate grounding path for sensitive electronic equipment. These receptacles have an additional grounding conductor that is isolated from the normal equipment grounding conductor. This helps to prevent noise from other equipment from being introduced into the grounding system of the sensitive equipment. Thirdly, surge protection devices, SPDs. Surge protection devices, SPDs, are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line disturbances. SPD divert the surge current to ground, protecting the equipment from damage. It's important to properly ground SPD to ensure that they function effectively. Fourthly, grounding electrode system. The grounding electrode system is the foundation of the grounding system. It consists of one or more grounding electrodes, such as ground rods, buried ground wires, or metal water pipes that are connected to the earth. The grounding electrode system provides a low impedance path for fault current to flow back to the source. Fifthly, bonding jumpers. Bonding jumpers are used to connect different metal parts of an electrical system together. This helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. Bonding jumpers are typically used to bond metal conduits, enclosures, and equipment frames. When working with electrical systems, it's important to use the proper tools and equipment. This includes insulated screwdrivers, pliers, and wire strippers. It's also important to wear appropriate personal protective equipment, PPE, such as safety glasses and gloves. Always de-energize electrical circuits before working on them. Use a voltage tester to verify that the circuit is de-energized before starting work. If you're not comfortable working with electricity, it's best to hire a qualified electrician. Electricity can be dangerous, and it's important to take the necessary precautions to protect yourself and others. Proper grounding and bonding are essential for electrical safety. By following the requirements of the National Electrical Code, NEC, and other applicable codes, you can help to ensure that electrical systems are installed safely and correctly. Remember, when dealing with electrical installations, it's always best to consult with a qualified electrician to ensure that the work is done safely and in accordance with local codes. In summary, the neutral wire carries the normal return current from electrical devices back to the source, while the ground wire provides a safety path for fault currents to prevent electrical shock. Connecting them improperly can create dangerous scenarios, potentially energizing metal objects and causing GFCIs to malfunction. For hot tub installations, always use a dedicated GFCI breaker, run a 3-wire cable, and connect the ground wire to the grounding lug on the hot tub and the ground bar on the electrical panel, never to the neutral lead on the breaker. Following these guidelines and consulting with a qualified electrician ensures a safe and code-compliant installation.